Okay, so 6.4, number 3, Foundations Math 20. This is the optimization. And what we're going to do is we're going to put together a system of linear inequalities to model a situation. We're going to come up with the objective quantity, and then we're going to find an optimal solution like in 6.5. Okay, so this is from scratch. It's an example for you to follow. All right, so a vending machine sells juice and pop. Okay, would be a good idea to now identify our variables. Okay, so if you want to, let's let J be juice and P be pop. That makes sense. Okay, frozen. Ah, there we go. So J be juice, P be pop. How's that? There we go. Buttons are working now. Okay, and so let's start taking a look at how we can now develop our system. Okay, what's the first one say? It says the machine holds at most 240 cans of drinks. At most 240 cans. So we've got juice and pop making up all of the cans, and we can't have any more than 240. What would be our first constraint here in this problem? Somebody just shout it out. Less than or equal to 240, what does? J plus P is less than or equal to 240. Perfect. Okay, that's the first one. Very good. Okay, sales from the vending machine show that at least 2 cans of juice are sold for every can of pop. Okay, these ones are tricky, right? At least 2 times as much. Remember with the variables here, I don't know, these ones seem to be tricky because I always get questions about this one. So let's work this through real careful. At least 2 cans of juice are sold for every can of pop. So the juice has to be more than the pop, right? So in order to make an equation, we have to double the smaller one. So that's where we start. So 2 cans, 2 times P is going to be what? Do you remember the pattern here? So juice is over here. So is this less than or greater than? J has to be at least twice as much. So J could be more than twice as much. J can be more than twice as much as pop. So that's looks like how you do that one. Okay, this one's good. This one's good. Okay, just once again, at least 2 cans of juice are sold for every can of pop. So juice is more than or equal to 2 times the number of pops. Pops are less than the number of juice. Okay. Each can of juice sells for $1 and each can of pop sells for $1.25. Okay, notice this is not attached to a budget, so this is not a third constraint or another constraint. Okay, it's not. So this is going to be what? What's it called again? It's not a constraint, it's not an inequality, it is the not obtuse. Obtuse, not opposite. Objective function, yeah. Hello. Am I the only one here?
Ambiguous case.
Ambiguous case. No.
That's not even started. No.
You are ambiguous case over there. Oh. Okay, no, objective function. All right. So this one is the objective function. We'll call it Q, right? Objective function. Okay. So this is going to be the cost. Look at maximum revenue, okay? Or I guess not cost, but cost to the consumer. So how much money is made, okay? So let's do this. Let's do revenue is equal to 1 times P. So just P, 1P or just P.
Just J.
Juice sells for, yep, you're right. I started here and then I saw pop, weird. Okay, so you're right, 1J. You guys are messing me up here with the ambiguous case. 1J plus 1.25 P. Okay, that's weird. Usually juice is more than pop. Okay. But this must be those small little juices. Yeah, juice box, that's what it is. Oh, probably. Okay, so you got that? I would not recommend putting the 1 there. Okay, but does that look okay? So now I've got a $sign with no number. I guess I will put the 1 there. Okay, 1J. Now, we should go back to the constraints though, guys. Really, we're assuming that there's more constraints here than we've written down. So let's write them all down. So what are the other constraints that we're assuming in this question that we should write down? Sorry? You can't have a negative number of either, right? Is there a minimum number of cans that they have to sell? Or does it say anything about that? It doesn't say a minimum number of cans. So pop has to be greater than or equal to 0. Juice has to be greater than or equal to 0. Okay, very good. That's everything. So in 6.1, 6.2, we've assumed a lot of this, right? We've talked about the limitations. But here, let's write them all down so that we don't have any questions. Yeah?
It seems like the juice would have to be less than or equal to 2 actually, because of it being twice as many as the
Well, yeah, that's okay. That's true, but we've got that taken care of with this one. So you're right. Let's just say we can't have negative, and that will be taken care of with this. You're right. Okay, but yeah, you could totally include that as well. Okay. All right, guys. So let's now let's graph this. Okay. So let's make a graph here, and let's put some lines in. Okay. So when we talk about juice and pop, which one do you want to be on the horizontal? Juice or pop? Does it matter? Okay, let's make juice here. Juice and pop over there. Okay, it doesn't really matter, but let's do that. Okay, so obviously pop has to be greater than or equal to 0. So we've got this, constraint here, and it's got to be greater. And same for this one here. Okay, we should say too that P is an element of what? Can we have all real numbers? Can I have root 2 pops that I'm going to sell? Whole numbers, right. Okay. So that's important too. So we're going to have dots, right? We're going to have whole number combinations. Okay. So how do we write, let's see, P. P is the this quantity over here. So this is actually 2P equals J. If I isolate for what the Y would be, this is going to be P equals 1/2 J. Well, now why would I do that? Because this is like Y equals 1/2 X. Okay, ladies back there? Shh. Please, no more talking now. Okay? P equals 1/2 J. That means we have a y-intercept of what? 0. What's the slope of the line? 1/2, right? So we go up 1/2. So let's try and mark some of these. Up 1/2. And again, if you got graph paper, that's ideal. Up 1/2. Okay, and you make your line there. My line function's not working right now. All right. So again, graph paper, ideal. Okay, so you can make a solid line there because it's or equal to. We know that there's going to be dots on the line, right? So you just realize that because of this right here. So you can make it solid, it's fine. All right, so is it going to be above or below? What's it going to be? Are we going to shade above or below? Let's pick a test point.
0.
We need to have more than twice as many juices. So let's say we take 10 juices and 2 pops. Is that going to work? 2 times 2 is less than 10. Is that right? Yeah. So we're looking at this region down here. Okay? We'll fill things in. Okay. Okay, so J plus P is less than or equal to 240. Okay. So we're going to have a pretty big graph here, to tell you the truth. I kind of went up 1 and over 2. But we're going to have to scale this so this is appropriate. I haven't marked anything on there yet, so this could be up 100 and over 200. Doesn't really matter. So 240. Okay, J plus P. So we need to find this equation. J plus P equals 240. And how are we going to do that? It's easy. This is easy because if you let J equals 0, then P is 240. So let's say 240 is up here. If you let P equals 0, then J is 240. So I'll make 240 down here. Right? Okay. So then you can draw this line as well. See if there we go. My line function is working. Okay. All right. And are we going to be below this region? Yeah? So down here? Okay? So obviously 100 and 100 is going to be less than 240. So that's good. So it's got to be less than. So you guys seeing where the region is here? It's got to be below this line, it's got to be above this line, it's got to be to the right of this line, and also below this line. So the region is going to be here, and I'll just kind of make some dots here. This is going to be your region, right? Make sense? All right. So now what I want you to do is I want you to stop and pause, okay? I'm going to pause here. I want you guys to find out, because we have everything listed here, including our objective functions. So we're going to look for combinations of J and P that give us the maximum revenue. So as we learned in 6.5 here, that the maximum revenue is going to come near a corner of the feasible region. So obviously, I'm going to give you a hint right now that making or selling 0 pops and 0 juices is not going to maximize revenue for your company, okay? So it's not going to be this one. Could it be this one or this one? What would be your guess? Well, it's going to be one of those two. So here you go. What I want you to do is I want you to find out what this point is. You figure it out. Okay? Find out what this intersection point is. You have the two equations, this equation and this equation. Find out what the intersection point is. All right. It's gonna take you, for a lot of these questions, it's going to take you a long time to do trial and error, so I wouldn't suggest that, although this one is not that hard. Okay, this is what you can do. Now, I've used P and J, so sometimes we'll use X and Y, which may make this a little bit easier, but it shouldn't be that bad. So what you want to do is you want to isolate for the same variable in both equations that you're trying to find the intersection for. So this one over here is going to be P equals 240 minus J, right? This one is P equals 1/2 J. So now you let the P's, or one variable, equal each other because we're looking for the point where the lines equal each other. And so you let these two quantities here, these two expressions, equal each other. So I'll do it in black here so you can see it. 240 minus J equals 1/2 J. So add J to both sides, and you get 1.5 J over here. Divide by 1.5 J, just by 1.5. And what do you get? What's 240 divided by 1.5? Or 240 times 2 over 3. Okay, so I'll just show you here. 240 divided by 1.5. So that gives you 160. So J would have to equal 160. If J is 160, you go back to either one of these original equations and you plug 160 in here. So 1/2 of 160 is going to be 80. That's going to be your point. So it's going to be 160, 80. That's going to be this intersection point. All right? So that's how you're going to do that. How do we get 80? Well, if J equals 160, do you see in this equation that P equals 1/2 of J? Right? That's one of our original equations. So you just plug, and you know what? You could have done it over here too. Like, for example, 160 plus P equals 240. All right. Okay, stay with me here. I know you guys get this. You guys can ace this, but let's just finish this equation. Then you can work on your assignment and ace it all. Okay? You're quite distracted this morning. So here's our points. We have 160, 80 is right here. What's this point right here? 240 what? 0. Okay? And obviously 0, 0 over here. So the final piece to this puzzle is we're going to take this objective quantity, and let's just move this down a little bit here. We're going to take this objective quantity, and we're going to plug in the 3 points to find out which is going to yield the maximum revenue. Okay? So revenue number 1 from point 0, 0 is going to be 0 times J plus 1.25 times, that would be 1 times 0, which is 0 anyways, plus this. So that revenue is 0, okay? That's probably going to be our minimum revenue, I'm assuming. Revenue 2, let's try the 241. So J is 240, so 1 times 240 plus 1.25 times with this point, there are 0, is that pop or juice? 0 pops, right? So we've got 240, okay? That's a candidate. Let's talk about R3 now. And R3 is this point. So we've got 160 times 1, and we've got 1.25 times 80. So what's that going to be? 160 and 1 quarter, oh boy, 100. Okay. So this is 260. All right. So do you see how these are the numbers for revenue? These are dollars. So from this you can see that this point, 160.80, right here, and this is getting pretty messy here, but this point right here represents the optimal solution. So that's going to make you the most money. Okay? So you'd finish that off with a word sentence, and then this whole question would be done. Okay? So you would say, selling 160 juice boxes, or whatever they are, and 80 pops would give you 200 and, would you say, 60 bucks? And the maximum revenue. So that's how you would finish your question there. All right. So I'll zoom out a little bit there. That's the entire question right here with everything in there. Okay. Any questions?